The goal of every atom is to have a full outer energy level, or a full octet in their valence electrons. A quick review. Here shown in pink are the metals. Remember, metals usually have 1, 2, or 3 valence electrons. That means they usually lose that 1, 2, or 3 valence electrons, become positive or cation ions. Here in the purple are the nonmetals. Don't forget hydrogen. And these, we're going to concentrate on the nitrogen, the oxygen, and the halogens. These have 7, 6, or 5 valence electrons, so they tend to gain electrons when becoming ions and become -3, -2, or -1 ions. Here we have two volunteers who are going to act out ionic bonding. On the left, Monica represents a metal atom. Let's say she's an alkali metal. So she has 1 valence electron, shown here by this monkey, and she tends to lose it because her electronegativity is low. She's a large atom, see the distance between her and her valence electron, and she's unattractive to that electron. On the right, Brie represents a nonmetal. Let's say she's a halogen. So she has 7 valence electrons. She's very attractive, has a high electronegativity for electrons. So a really strong pull on electrons. Let's see what happens when an ionic bond is formed. Okay, so here you see Monica has completely lost her electron. Right? She no longer has it, so she becomes a cation. Brie, on the other hand, has taken that electron. She's stolen that electron. Nonmetals steal electrons because of their high electronegativity. Right? And now she has her full octet because she had 7 and she gained 1 electron. Monica also has her octet because she lost her 1 valence electron, and underneath in the next energy level is a full octet. So both are relatively happy at this point. Again, Monica is a cation, and Brie has become an anion, the negative charge because she's gained an electron, positive charge because she's lost an electron. Now that we have a positive cation and a negative anion, there is an attraction between the two called electrostatic forces, and that's going to bring the two together. And this is your ionic bond, this connection between your positive cation and your negative anion. For that reason, we need a metal and a nonmetal. Metals to form the cations, nonmetals to form the anions. So a quick recap. Ionic bonding involves stealing electrons. The nonmetals, they're the thieves. They have a higher electronegativity, so they steal electrons from the less attractive, lower electronegative metals. So you end up with a cation bonding with an anion, held together by electrostatic forces, the attraction between the positive cation and the negative anion. Covalent bonds are quite different. There's no stealing of electrons like there is in ionic bonding. Here we have 2 nonmetals that are going to form a bond. Since both have a high electronegativity or are very attractive to electrons, they're not going to be able to steal electrons from one another. So they're forced to share the electron to fill their octet. Here we have 2 nonmetals. We chose sisters, Kimberly and Michelle, to represent the atoms because it's easy to see that they have equal electronegativity or equal attractiveness to the electron. Here's the electron represented by this monkey in the middle. So both are going to pull on the electron, shown by the rope. Yet as you can see, neither one is stronger than the other. So the electron remains in the middle. Now what's bonding them together is each of them pulling on the electron. It's this pull that keeps the molecule or the compound together. Right? Since they're both pulling on the electron, the 2 atoms are now bonded together in what we call a covalent bond. Now this, since it's equal pulling, we call this a nonpolar covalent bond. Nonpolar because the electron more or less is equally shared between the 2. Right? Equal electronegativities or close to equal allows for equal sharing of the electron. Sometimes one atom is more attractive than the other, but not attractive enough to pull the electron completely away. That's what we call polar covalent bonding. Again, we have our 2 volunteers, Monica and Brie. Remember Brie, we're going to still have Brie be a little bit more electronegative, but they're both nonmetals this time. Monica is going to be a little less electronegative. So although they still can't steal electrons from each other, they're both going to pull on the electron, or the monkey represented in the middle, but they don't let go. So these two atoms now are bonded together, but the electron is a little bit closer to Bree because she has a higher electronegativity. It's a little farther from Monica. She's still got a handle on it, so it's that connection between the electron that actually connects the two atoms. Now this is called polar because this end, where Bree is, where the electron is going to be a little bit more negative. And this end, where Monica is, farther from the electron, is going to be a little bit more positive. So this compound, or this molecule, is going to have a little bit of a plus charge here and a little bit of a negative charge on this end. Like two poles on a battery, like your plus and minus end of a battery. And that's going to make that molecule act a little bit different than our previous non-polar molecule. Here's some questions for you to answer about the video. Please make sure you write the question and the answer on your paper. I'd also like to thank Kim, Michelle, Monica, Bree, and Lachey for all their help in making this video. If you're interested in helping out with the videos, let me know and I'll make sure you're in the next one. Thank you.